Ladies and gentlemen, Flyability fans, innovators, surveyors, inspectors, all of you here in this room in Lausanne, all of you here online with us, looking for the next innovations for keeping people out of harm's way, welcome to this live broadcast event. I'm Adrian Bryant, co-founder and CTO of Flyability, and I am super excited about the innovations we're about to share and release. For the last 10 years, our motto has been no more humans doing dangerous jobs. And it's really, really inspiring to see how you all are making this happen in reality on the field. This is just an extract from 1 week on LinkedIn where some of you have been sharing how you are mapping historical sites like Alcatraz, doing landmark missions like in the Victoria train station, or doing all sorts of industrial inspections like inspecting boilers, the internals of wind turbines, inspecting shafts, of course, building digital twins of various assets, exploring tunnels, mapping out cavities and mines, and even in mines doing some pretty impressive missions doing the rescue of mining equipment that got stuck. You have been helping out in the collapse of a tunnel, inspecting sewers, or tunnel storm drains, or penstocks, and so many more things. You are truly Flyability fans, and you are our heroes, because every day you are doing critical work. You're keeping safe infrastructure that all of society uses and is crucial. So, big thank you. Over the last 10 years at Flyability, we've shipped more than 2,000 confined space drones, starting in 2016 with Elios 1, which was really a one of its kind. We introduced the first commercial drone that can fly indoors and collide into things and survive collisions. Then we brought Elios 2 with a step change in ease of use and in terms of capacity to inspect as well. And then Elios 3, 2 years ago, with a big promise that it was a platform that we would keep building on top of. And we delivered last year some payloads for Elios 3. The radiation payload, allowing to map out radioactivity in critical nuclear use cases. The surveying payload, mapping never-before-mapped places with high accuracy. We've also released many software updates. And by the way, today we're launching a big new software update. But first, let me tell you about a new payload for Elios 3, a long-awaited payload that is the fruit of 5 years of R&D. We have filed 3 patents along the way and have done 100 missions with beta testers to get real-world feedback into this product. The wait is finally over. Discover with me the new Elios 3 payload. Ladies and gentlemen, say hello to the Elios 3 ultrasonic testing payload. So why bring UT on a drone? That's an easy one. You know, measuring the thickness of metallic plates or metallic components is the most requested data after visual inspection for the inspection of so many critical assets. And today, that sort of inspection requires work at height, building scaffolding, using cherry picker, doing rope access. And here, with Elios 3 now, having ultrasonic testing capabilities, and of course, visual inspection capabilities, we are really bringing the ultimate inspection tools to many industries, like in the maritime industry, in oil and gas, chemical, power generation, and so many more. We really believe we'll revolutionize many use cases. Why UT on Elios 3 specifically? Well, Elios 3 is designed for contact. I mean, it's been 10 years we build drones that survive collisions, that can handle contacts, which is really, really hard. And UT is a contact activity. So what is hard for most conventional drones is really natural for Elios 3. This product would not have been possible without the amazing partnership with Cygnus. Cygnus has 40 years of experience in reliable ultrasonic measurement, and we collaborated very closely with them during the entire development to bring high precision, high reliability ultrasonic testing on this product. So thank you, Cygnus, for this amazing partnership and the years to come. Now, let me tell you, just zip tying a payload on a drone, handheld probe is very easy. But making a product that allows you to be safely on the ground and feel like you're up there taking a UT reading and be very efficient at that is very, very hard. A lot went into this product, and so that's why I am super excited to welcome Stefano Zampieri, product manager for the UT Payload, who will tell you more.
Hi, everyone. So as you understood today, we are giving you the possibility of taking thickness measurements in confined spaces. So as Adrian mentioned, Elios 3 is a contact drone. It's very good at doing its job. But on top of that, we developed 6 main features that will allow you to perform flawless UT inspections. So I'd like to dive into each one of those features with you so that you understand a bit more what they are. So as a UT inspector, the most important point that you'll have is to make sure that your measurement is correct. So 5 years ago, when we started to fly our first prototypes, we realized that just a simple digital reading is not enough to trust your measurement. That's why we are sending 8 A scans per second to the piloting screen so that the pilot can assess the validity of the measurement. So it looks like this in real life. So we have the A scan overlay on the piloting screen. We have the digital reading on top of the A scan up there. And if you want to go further, you can even use the manual gates and gain to adjust and refine your measurement if needed. So to get an A scan at all, to start with, you need coupling. Coupling is an essential part of UT operations. And that's why we developed a smart couplant dispenser that is made of 3 main components. So fast swappable syringes to minimize downtime in between flights when you refill your tank. We also have a gel gauge on cockpit. So while you fly, you always know when it's time to come back and refill your gel. And an optimized couplant dispenser, which, when you fly a drone, most of the time the drone is up there. You need to trust how the couplant is dispensed. And that's why our brilliant engineers developed this smart and very efficient system, which is just a lip around the probe that forces the gel in one direction to remove air bubbles and debris from the front of the probe. When you will use this tool, you will not only want to take measurements on vertical walls, you'll also want to take measurement on ceilings and floors. So that's why the probe can be mounted on top, in front, or below the drone for all those situations. But you can go further with this tool. For example, here you see a drawing of a pipe rack that one of our engineers made in the field. And in this situation, you need to take measurements in between the pipes where it's very tight. The drone cannot fit there. So you can shape the arm of the drone in different shapes to access all the inaccessible points that you'd like to take. So when you fly Elios, you must know that you will for sure get in contact and touch things. And as the probe stick out, we made the arm flexible. So if the probe hits something while you fly, well, the arm bends and leaves the drone alone. So we have a simple example where it can be useful. Here the drone tries to enter a manhole and the probe hits on top of the manhole and the arm bends and the drone can fly uninterrupted. We also added a laser in the probe. So, as a pilot, you can only look at your piloting screen and you don't have the perception of depth. But the laser creates a reference point on the wall that can be used from the pilot to adjust the position of the drone and hit a very, very precise target. You can see here how precise it can be. So, you'll not only have pipes in your assets, you will have also flat surfaces. And that's why today we'd like to introduce the concept of interchangeable probe hoods. So this part goes around the probe and adapts the probe to the surface you want to measure. For example, for flat surfaces, you want a hood with 3 magnets that keep the probe very stable against the surface and perpendicular to the surface. For pipes, you want 2 magnets so that the probe is aligned with the axis of the pipe. But today we are not only launching probe hoods, we're also launching interchangeable probes. For situations where you have thin walls or small pipes, you want to use the 7.5 MHz probe, which is more adapted for those situations. For general use, you have the 5 MHz probe. And for rough conditions where thicker walls are there or dirtier surfaces are there, you want to use the 2 MHz probe, which is more powerful. But sometimes surfaces can get even dirtier than that, and the 2 MHz probe is not enough. In those cases, we have the cleaning module. The cleaning module is a metallic motorized brush that was optimized to be carried by Elios 3 and can be plugged instead of the probe on the drone, and then you can fly to your surface, you brush for a few seconds, and that's how it looks like from the other side of the wall, and then you detach and it leaves a very clean spot ready to be measured. So, you know, I like this picture. I like it because it shows how thickness measurements today are noted, marked on the assets. So it's very efficient and simple. However, this can be erased, and when I look at it, I have no idea when the measurement was taken. So from today, you can mark digitally your measurements on the 3D map that Elios produces, so that you can come back even 2 years later on the exact same spot and compare your measurements. So the fact that Elios 3 can carry both LiDAR and UT also gives you a big advantage that we call situational awareness. So when you fly for the first time in your asset, and you need to take measurement, for example, on a stiffener on the roof, well, all the stiffener, they all look the same. So only from the camera, how do you know you're on the right one? Well, you can zoom on the map on the piloting tablet and make sure the drone is aligned with the right stiffener before taking your measurement. So now we have all the tools, we go for our inspection, and all the flights will be recorded in the memory of the drone. So we can go home, plug the drone to our computer, and use the inspector software that goes with Elios 3 to virtually navigate in our asset, like in a video game, and relieve our inspection. So you see the green dots here are our point of interest that we took during our inspection. If you open the UT tab, you can find all your measurements there. And by clicking on the point of interest, you'll have the associated measurement directly. So all the measurements are recorded, not only the ones that are associated to point of interest. So if you forgot to press this button during your flight, that's not a big deal. You can go back in the timeline and find every single A-scan and measurement that you'll have. You can also leave comments and criticality levels on the point of interest so that the next person who's using this tool and taking over of your inspection can actually know what you were doing and have your comments there. Now, to develop all that, we went on the field. We had many iterations, and I'd like to share with you 2 simple inspections that we did with the company Inspect Drone in Germany. The first one is this simple silo cone. So we had to take 10 measurements on this silo. They were 4 meters high, so we can take measurement on the map. And 4 meters means probably work at height. You have to build scaffoldings. you have to think about it, and it's time and money. And here it was just one flight with the drone. You take off, you go around, you go in contact, and you get all your measurements in 5 minutes. The other example is this flue gas duct. It's a bit more scary. It was 15 meters down, the measurement that we needed to take. And here, without the drone, you would need to go on rope access down this pipe. It's cold, it's scary, you have debris that can fall down. The structural integrity of the asset maybe was questionable. So here, it's just a matter of flying down to the right section. You can see on the left, you can track the drone on the 3D map. And then go in contact and get your point. And everything will be stored on the drone. And then you can go home and have a beer with your friends. So that video concludes my presentation, but I'm extremely excited to see what you will do with this tool and all the crazy inspection that you'll perform. Thank you. On that note, I'll leave the microphone to my colleague Mark for another extremely exciting product.
All right. I can feel the energy and the excitement about this new payload, but as Adrian said, we've got one more thing we'd like to share today. And this thing is software, and it's going to completely change the way you look at your data. This software is called the Asset Management Extension because it is an extension to Cockpit, the piloting app, and Inspector, the data processing software. It's a software that turns drone data into a consolidated view of your asset. And what do we mean by that? I mean, if you're familiar with drone-based data capture, you know that pilots, they work one flight after the other, and each flight equals a set of data. But that's not the way asset managers are looking at their data. What asset managers are interested in is actually their asset and the state of their asset last time it was inspected. And the asset management extension is actually here to bridge the gap between those two worlds, the flight-based data capture and proper asset management. Now, how does it do that? Well, it's quite simple. By organizing and merging subsequent flights into a single frame of reference so that all your maps and your points of interest are all aligned on the X, Y, and Z axis, and then they're aggregated with all the video into a single data set that represents one inspection. How does that work in practice? So next time you'll go in the field and go back to an asset you've already inspected, when you will fire up the drone, you'll see a ghost map that was captured previously, and you'll see that on your tablet. Before taking off, you'll perform a little trick that we call relocalization, which is giving a chance for the drone to find back its position within the historical map, so that when you fly, every data that you collect is aggregated to that global asset map that you have and that you're building a long time. So this is how you're going to aggregate all your flights into a single data set for the inspection. Now, it's not only about the map. POIs, or points of interest from previous slides, will be visible as you fly further along in the inspection. And this is extremely useful when you do inspection that contains a lot of flights. Let's say you have 20 flights to perform, and you want to know which part you've covered and have you covered it properly. Here, by looking at all the points of interest you've captured in previous flight, you'll be able to track where you stand within your inspection. Now, if you've been in the field, if you've done inspections, you know assets are not always open. They're open for a fraction of time, sometimes a few hours in the day. So that's your moment to capture the data. And if you come back to the office and realize that a part of the data is missing, well, it's too late. So we hope that with this feature and your ability to track inspection, you'll be able to always leave your site with a complete data set. Now, this new software extension comes with a major release of Inspector that we call Inspector 5, where we have completely redesigned the way we organized data. If you've used Inspector 4, you know one flight is one folder with data inside. Now, in Inspector 5, we've changed completely that, and we introduced the notion of workspace so that you can switch from one project to another, or potentially from one client to another, and get all your data loaded into the software. Because each workspace contains a series of assets, which in turn contains inspections and then flights. So this is how the data is structured inside the software, and this better reflects the way asset managers are actually looking at data. Now, we've also redesigned the viewer, the data viewer inside Inspector. We call it the asset-centric data viewer, and it has a unified video timeline at the bottom where all the videos are aggregated and displayed in chronological order so that you can review each video all from a single interface and jumping from one video to another. We also revisited the feature where, when you click a point of interest, not only will it seek the right frame, but it will seek the right frame in the right video. So this way you really have a synchronization between the 3D model that you have in all your points of interest and then the data, the visual data that goes along with it, and as Stefano mentioned, also the UT data, and so on. All your flights and your maps, they will be displayed as a single map, but if you want to know which map belongs to which flight, you can still colorize flights or maps, according to flights. And finally, if you want to work only on a fraction of your inspection, you can also select individually the maps and the flights that you want to display in the interface. So those are handy features that will help you review your data. But we've also improved reporting. Well, when you're done capturing data, reporting takes quite some time. And working with Inspector 4, you had to produce one report for each flight you've done to then manually copy-paste the data into a final report, which is a long process that is time-consuming. I'm pleased to say that now this is over. You'll have a single inspection, and you'll be able to work on all your points of interest from all your flights and produce one single report right from the data viewer. So I'd like to show you some use cases to illustrate the benefits of this asset management extension. Here, this is a sugar factory. It's a warehouse in a sugar factory where the mission was to actually check all the fixing of the rack joints, right? This is a mission that typically involves work at height and a risk of falling debris, right, and falling objects. So it's typically a good mission for Elios 3 because this warehouse is fully automated. Nobody walks in there usually. But for an Elios 3, it can get very tricky in terms of situational awareness because look at that. This is how it looks in this factory, right, in this warehouse. It's hundreds of meters of aisle where things are all similar. And you have to check any of the rack joint, as we'll see here. So that's really what the mission is about. Pretty simple. Checking, oh, we have the fixing there, no problem. Then going to the next joint, fixing is there. And repeat that task 1,000 times. So this client has used the asset management extension to track progress of their inspection, and they could ensure that when they left the site, they had checked every single of those 1,000 rack joints. And I think this is really making an impact on what you can deliver to your clients. Another inspection that I think is worth mentioning is this spherical tank that was inspected by Stefano while he was testing the UT Payload. So the goal of the mission was to complete a full thickness gauging of that sphere. This has taken 37 flights and ended up in almost 300 UT spot measured. And it's a task that you have to do one flight after the other, completing, all those points that you have to capture. This is a task, if you have to remember everything by hand, by heart, in your head, which points you've actually measured, it's impossible. So you need somebody else somewhere to track your work. Here with asset management, Stefano was able to perform that alone. This mission actually took about a day. It actually took more time to get the permit to perform the inspection than doing the inspection. And this is a mission that usually takes several days if you perform that using rafting or scaffolding. I'd like to show you this video because this illustrates why we'll say that NDT will never be the same again after we launch these two products, because I think this is really what asset managers are willing to see eventually as a deliverable of the work you do. It's a full digital twin of their asset with all the data points pinpointed where they are taken, where you can easily click on one and get the result of the information that is lying behind that defect. And with that, we're concluding this product launch, and I'd like to invite on stage a few of our product advisors to continue our journey on UT. So I'm just going to introduce them to you one after the other. Give me a second for turning on my phone. I need a few notes. So, serial innovator, co-founder of Cyberhawk, and today CEO of Seabird, Malcolm Connolly has worked in the NDT business pretty much his entire life. And beside his unique ability to play bagpipe in cargo tanks to celebrate major achievement, yeah, we'll touch base on that in a minute. Malcolm is highly knowledgeable about the intricacies of NDT inspection in oil and gas and maritime industry. He's always ready to put our system to the test. And he's been instrumental in the development of the Elios 3 UT Payload, so we can't thank him enough for that. Please welcome Malcolm on this panel. President at Osprey Integrity, Cortland has worked as an air ambulance and corporate pilot, as well as flight instructor for several years before turning to the world of NDT. He's a multi-ticket NDE, UT Level 2, certified API 510 pressure vessel inspector, among a lot of other, actually. And Cortland runs Osprey Integrity, a company based out of Cochrane in Alberta in Canada. It's a company specialized in aerial non-destructive testing, data collection, analytics. Please welcome Cortland to this panel. General manager for drones at Acheron. Danny has worked in the aerial inspection business for the last 10 years. He's highly enthusiastic person, and yet with a very transparent and sharp feedback. Yeah. He always opened doors to Flyability for testing products in the real world. Please welcome Danny. And finally, product manager for the UT Payload, Stefano holds a master in mechatronics, robotics, and automation. He's been with Flyability for the last 6 years, first as a mechanical engineer and now as a product manager for UT. Please welcome Stefano. Got my hands full. Cool, so thank you, welcome on this panel. So the idea is to let this audience know a little bit what we've been doing in the background before today together. And I'd like to start with one question for you guys. I think I want to know what you think this new product and UT on a drone will change in the NDT business. I'd like to hear you first, Danny.
Thanks for having us. Really on my end with my experience is how do I deploy something like this at scale? So I start to think of what are our use cases, but really to simplify it is it's an extension of an inspector's arm, right? So if I have a UT measurement up here, even if it's 4 feet higher than where I stand right now, I would have to do some sort of alternative access to get there. So the simplest way to put it is making my arm a lot longer than it is now to reach that and do it much more efficiently than before. Good. And I don't know if, Malcolm, you have some point of view or something to add to that.
Yeah, just to add to what Danny said, the Elios is an access platform, and the UT Payload it's a delivery of a sensor that's that you could deliver by rope access or scaffolding, but this is a much more efficient way of getting to an area at height and capturing useful inspection data. And as Adrian mentioned in his opening speech, after visual inspection, the biggest use case in any kind of inspection is spot thickness readings for ultrasonics, and that's, you know, the next tier of the inspection pyramid. So yeah, huge useful.
I think while we were discussing preparing that session, you mentioned that there's actually quite a lot of inspections that are satisfied fully with visual inspection and UT gauging. Can you let us know a bit more about that?
Yeah, sure. So there's a couple of use cases where you can meet the entire regulatory requirements for an inspection by a general visual inspection, which is like looking from far away, close visual inspection, which by definition is something you can touch as a human, and then spot thickness readings with NDT. Now, the outstanding use cases where you can complete that entire regulated requirement are in the marine industry, so your class certification. This is a little bit like doing a MOT on your car. It's a regulated requirement. You have to do it at certain time periods, but obviously for an oil tanker it's a bit more involved than taking your old Ford Escort in for an overhaul. Yeah, so with the Elios UT, you now have the capability of being able to complete all of the requirements for a class survey without having to do any kind of scaffolding, rafting, rope access. And that's going to be game-changing for the marine industry. Other onshore applications would be bulk storage tanks, so API 653, EMEA 159. You can complete the vast majority of the inspection requirements with the spot thickness reading for the shell course, the roof of the tank. You still have to do full tank floor scanning, but that's a different bit of equipment. Yeah. But yeah, for any of the working at height requirements for bulk storage tanks, you can complete that with the Elios 2. Well, Elios 3, sorry.
Gives you a
I've been using the Elios 2 for too long.
Yeah, Mark has done a lot of tests also already with the Elios 2, testing some prototypes of the probe. But Cortland, I don't know if you have anything to add in how this is going to shape. I mean, having UT on a drone, how this is going to shape and change this NDT business.
Yeah, so one of the things that Adrian said the Elios product does in general is optimize that uptime. It's minimizing asset downtime. So the visual, when we look at something, we have an idea that there might be something of concern, but it isn't always. So sometimes we'll call for a follow-up, and that can be a tedious process that requires the cherry picker, the crane, scaffold, ropes. But now, with something like this, in very complicated environments, we can go and quantify that visual finding and know if it requires any kind of more in-depth follow-up or if that's good, right? It might look terrible, but be fine. So this is a very quick tool to be able to go in and quantify and then move forward.
So overall, it helps you, let's say, optimize how you will involve cost in this inspection by being sure that, well, if something has to be done, you put the scaffolding only in the part that needs to be further assessed, right?
Exactly that. So the fact that we've got the spot reading and it can be fit for purpose in some cases, at the very least, worst case scenario using a tool like this is that we can strategically direct where the follow-up money needs to be spent, if at all, right? So now it's justified spend.
That's great. It gives us a good overlook. Now, I ask you guys to send me some videos and pictures. I'm gonna play them as we talk about it. And starting with you, Cortland, you sent me that inspection. So let me play that. So can you explain a little bit what that is?
Yeah. So this is called a once-through steam generator. We've been using the Elios platform for about 3 years now to do the internals above the convection section. So now, you know, we've historically gone and seen things like dew point or general corrosion and just things that are of visual uncertainty. So yeah, this was with Stefano on a very cold tundra day. You were calling it the tundra, I think? Yeah. So yeah, this was during, obviously not the way it looks today, but going up through the dampener of this stack because it is insulated. Just being able to go up and quantify, again, some of the thickness measurement to make sure that there's enough meat there that doesn't fall over.
Yeah. And you told me something about the type of gas and the corrosion.
Oh, yeah.
I'd be interested to know more about that.
In some cases, they use a gas to fire the boiler that has H2S or trace amounts of H2S in it. So when you get rain or moisture, you can have sulfuric acid develop by having moisture in the H2S mix. So what we see a lot of times in these stacks, in particular up towards the top, is a general corrosion mechanism, which spot thickness is totally fit for purpose for general corrosion. And yeah.
Cool. And finally we get a reading. So you see it's quite a tricky access, but we finally get a reading in there, and amazing to see that. Amazing.
Thanks.
Well, I got another video that if I can skip through. Yeah, Mark, you sent me that. You got to tell us what's that. Seriously. So it's actually Mal playing backpack in a cargo tank. So what's up with that?
But there's probably two main reasons. I'd say the first one was I'd run out of places to play without getting complaints from people about the noise. But the second reason, it was it was kind of a celebration for the culmination of quite a number of years of work with one of the major class societies, a vessel fleet operator, and Flyability and Seabird. We'd been working on both the hardware development for the UT Payload, but in parallel to that, the regulatory development and acceptance of the technology ahead of you suddenly come out with a new piece of technology to then go through the regulatory acceptance process would be another long time. So we tried to do the two in parallel, and playing the pipes in the cargo tank, that was a celebration because Seabird had just been given the very first specialist vendor certification as an ESP hull gauging company that was able to use drones to do ultrasonic thickness testing for class survey. So that was the middle of last year, and that was after 4 years of working with the early stage prototypes, and
yeah,
that's getting to there.
That's worth playing backpack in a cargo tank.
Yeah,
I think.
Thank you.
But I mean, I think you sent me also this other video that shows some of the work you've done. So this, can you explain what we're seeing on those images?
Yeah, so I mean, this is more of a demonstration video rather than actually how we would typically carry out the workflow. But what it was essentially trying to show is that you can now perform a type of inspection. So in this case, the class survey of an oil tanker by sitting on the deck. You don't have to go into the confined space. And because of the data localization, you don't need to actually physically see where the drone is, because I think, like Stefano mentioned earlier, a lot of these structures are very uniform. It's easy to get lost. It's easy to not be inspecting the right part of the asset. But with the combination of the laser scanner on the Elios 3 and the UT, you can now meet potentially the regulatory requirements without having to actually physically see what you're doing, as in the drone. So yeah, just to give you an idea, to get up to the area here, which is just under the deck plating, that would take a team of 15 scaffolders 2 days to build the staging to reach that, and that's passing every single scaffolding through a little manhole. So it's a huge amount of work to get up to there, and that's 2 minutes, boom, boom.
Yeah, and I think it goes beyond that, right?
It goes way beyond that.
Yeah, a ship that is not at sea is a waste of money, isn't it?
Yeah, absolutely. So typically, depending on the age of a vessel, our clients can spend anywhere near up to $1 million on staging alone to carry out the survey, and they get nothing for that other than the, the certification. There's no new coating, no nice bit of mechanical work done. That's it. It's it's
So
a lot of Lego for not a lot of.
Their CFO must love you.
Yeah.
All right, Danny, you also sent me a few things. Starting with those pictures, I think they're interesting for a lot of reasons, but I'll let you tell us why.
So in these pictures here, I'm inside of a fixed roof tank. So versatility is really the message here. Is we're able to adjust the probe and fit into areas that otherwise would be very difficult to get into. So Stefano talked earlier about the adjustment of the probe, the mounting locations, and really the key here is establishing a workflow so you can complete your job as efficient as possible, right? So if you're doing this I-beam here, for example, you'd want that forward-facing probe, but you can also go into an I-beam and turn up and in. The same way we talked about the pipe rack. So it almost like that human arm, again, going up and into the pipe rack, where traditionally if it was a fixed mount just in the front, you would be stuck just going straight forward or straight to the side. But reality is we have lots of tight spaces, which goes back to the mantra of flyability is accessing those inaccessible places, and the product is designed to do that. So in this case, again, it's similar to a lot of the other examples we've seen, where you're able to go and cover these large areas that otherwise would be very expensive. It looks a lot like Malcolm's example. It's just not floating in the water.
You also sent me that saying this was one of the key aha moment for some of our clients. The drone is actually up there if you can't see it, right? So what's that?
So UT for pipe racks is really what we're talking about here. So we all know that in the facilities where we work at, we have miles and miles of pipe racks. Everybody's facility has it. It's transporting some sort of product. People tend to say that NDT is the art of keeping the liquids inside of the pipes that they are meant to be inside of. The containment type of mentality, which is obviously important. So in this case, we're aiding that high volume inspection, right? So think about how many miles that you have of pipes. Think about how many readings you need on those pipes. Think about how many inspectors we have just in our company doing those sort of things, and scale that to the world. And this is really the most powerful use case that I've seen. So in this case, we're able to fly up and go to non-insulated piping and get readings really however we would like. We don't have limitations based off scaffolding position. We don't have limitations based off access. So lots of versatility here as well.
And maybe hinting back on my first question, you told me one thing that I found very interesting when we discussed earlier. You said that with visual inspection, your drones were up in the field pretty much 3 months in a row, fully loaded, and then kind of sitting on a shelf waiting for the next shutdown because the type of work you can do is limited. Is that going to change that for you?
Yeah, thanks for bringing that up. So the Elios traditionally has been somewhat lumpy, right? Like we have enough work where we, for the most part, have outages for the entire year. But as everybody knows, it's seasonal, right? Everybody wants to do outages when it's not in extreme temperatures, hot or cold. So in this case specifically here, what this enables us to do is to have stability of a workload with this product, right? So for whether you're an asset owner and you want to implement this into your everyday activities, or if you're a service provider, it's something that you can consistently use every single day. It can supplement existing data. It can replace the way you're doing things right now and do it much more safely. So it's a win all the way around. I'm all about win-wins and win-win-wins, and this fits in that bucket.
Yeah, thanks for commenting on that. Now, I think we haven't heard you, Stefano, but I didn't ask you to send me pictures because you sent me a truckload of things already, and I couldn't put them all here. But I think you've tested in so many places during those 5 years. And can you tell us some of the craziest places you've been testing that thing?
Okay. Well, yes, I can. I've tested this in so many places. Which one was the craziest? Well, I think the craziest, maybe most challenging, was a ball mill in a cement plant. So at Flyability, we like to call cement plant the hell of a drone because it's like super, super dusty. The drone doesn't see anything. And so the ball mill was extremely dusty too. And the entrance was very small. We had to deform the cage of the drone to put it in there and then start the drone from there. And I was very lucky that we had, because before the stability of the drone was only based on the cameras. Now the LiDAR helps as well. And the LiDAR sees through dust. So at this point, we finally had this, and I managed to fly in the dust and reach the exact spot in the ball mill. So it was those plates, protection plates. They were monitoring the abrasion of those plates. And so we could actually measure them. That was very stressful and very crazy, and there was no way of entering the ball mill. So we could lose the drone completely.
Yeah, so putting our prototypes to the test and possibly losing them, right?
Oh yes, yes. This one was a tricky one.
Those prototypes that we take weeks to build, by the way. You told me about one of those anecdotes. You found something very weird on that sphere, didn't you?
Oh yeah, so you all saw this sphere before where we had hundreds of points. Well, yes, so that was not, I wouldn't say it's a crazy place where I flew the drone. Tanks, we often go in tanks. However, the use case was pretty strong because it was insulated from the exterior and very interesting because to inspect a sphere, the scaffoldings are very tricky to build in there. And so they usually fill the sphere with water and then go with a little raft inside and then empty it. So I don't know how long it takes to fill a 25 diameter meter sphere. But yeah, by inspecting the sphere, we were doing layer by layer. And at some point, we found a reading that was completely off and we were like thicker than what was expected. And like maybe the system is not working. We didn't know. Then we keep going layer by layer. And the next layer, we have also a reading that is off. And then third layer off. And then at some point, after we processed all the data, well, we noticed that all the readings off were all in the same plate. And so basically, they used one plate that was way too thick. I think maybe they ran out of thin material and they reused something else. So it was fun to find something that they didn't find themselves thanks to this tool.
Well, you were actually questioning the technology. It was questioning the engineer that built the sphere. Yeah.
I mean, I'm used to have bugs when developing, so.
Yeah. Well, I'd like to hear if there is some places you already foresee where you want to deploy this technology further. I don't know if any of you want to take up in this question.
Yeah, I mean, Danny, has the top one, at least for the world that I come from as well. I think that pipe racks in those complicated spaces, building integrity, especially with what's going on around the world with aging infrastructure. Right now, I think that's a massive win. Just trying to figure out in those condition assessments what kind of remediation or what kind of repair is going to be needed in that aging infrastructure. There's a fit there to kind of take a non-oil and gas lens at it as well.
Danny, any places you foresee you'd like to deploy that technology there?
I think in power plants, for example, there's a lot of applications where they're hard to access, and right now the strategy is to collect as much data as possible, and sometimes they don't need that much data, right? So quicker, shorter turnarounds. As a whole, we're seeing shorter, call it pit stops, right? So shorter turnarounds, so time is more precious than ever. So turnarounds are always a big use case for this aircraft since the Elios 1, but even more so now. And then offshore, we do a fair amount of offshore work, and right now, similar to what Malcolm's saying, is like you have that tier of the GVI, then the CVI, and then the next tier is UT. So we're at GVI, CVI right now. We're excited to enter into the UT because it just continues to add value to the customer and everybody is happy. So the uses are really, really endless.
I was just going to add hydroelectric. So for the penstock and down into the turbine kind of area as well is someplace. Yeah, 100%.
Yeah, we don't always think about those places, but they're crazy. Yeah. Mark, anything?
Yeah, I mean, so Seaver's focused predominantly in the marine industry, but I think the timing of this is actually pretty good in terms of another emerging kind of industry, which is the floating offshore wind. Now, because they're floating structures, there's still an unknown about how these are going to be, if they're going to fall under class regulations or not. If they do, then you're going to have basically autonomous or structures with no people on them that have autonomous ballast systems, very, very difficult spaces to get into or out of without shutting the system down and isolating it. So that's quite difficult to do if you've got a large wind turbine that's relying on the ballast system to keep it upright. So I think this tool, in combination with actual underwater ROVs, will be the way to meet those requirements when they actually get defined. They're not defined yet, but it's maybe a parallel development of the two at the same time. That's all I would have.
Good, good. Well, there's one question I'm really interested to hear you about. I mean, Flyability is not the first company to build a UT payload on a drone. That's been done already several times. Yet, at least my feeling is that we're not to a stage where it's been streamlined as much as visual inspection with drone is streamlined today. And I'm wondering if you guys think that this UT payload on the Elios 3 is going to change something to that, and if so, why is it going to change something? I don't know if any of you want to take up this question. Maybe Danny, you want to start?
Yeah. So I think there's some clear leaders in the industry of the UT drones. I think we're still in the infancy. The key is education and collaboration. So on the education front, that means everybody's goal should be to be a teacher, right? To teach your customers, to teach your employees, to teach your partners. And that's really going to help grow what's possible with this and ultimately save lives. And then collaboration is the technology companies working together to get this at a faster pace, right? Because ultimately, the hurdle is people have been doing and managing these assets for many years without us, right? So why would they want to change? And that's been since the Elios 1, the same. And we've proven through the years that the change is worth it. But there's still more struggle. There's still that education. So I think that overall, everybody should kind of try to work together to educate the market as a whole. But in terms of differentiators, always it's the same theme and the same culture that we've seen with Flyability since the beginning is it just works. Whenever you're in the confined space or right outside the confined space, you're under pressure and you have 10 people watching and you're sweating and I live in Louisiana and it's really, really hot, the Elios performs. And it performs over and over again. And that's the difference between this and many, I guess, competitors that are out there. It performs when it matters most, and it's been doing it consistently for me since the Elios 1, and we have many of these things, and it just works. So,
Corlin, do you have any other opinion?
Similar opinion. I would lean towards this being a really cohesive total product. So when you look at the hardware, yes, to your point, there's been UT on a drone before. It'll likely continue to happen. But when you look at the inspector platform and the centralized asset management tools that you have created with the situational awareness for repeatability, that I think is a differentiating factor right now. The ability to know exactly where that point was taken in GPS denied environments is massive. That's a very difficult thing to solve. So this tool right now does that.
Good. And well, Mark, as always, you send me funny videos. So I'm going to play that for you because, and you can explain what that is, right?
Okay, yeah. So this was around 2015 maybe, and I think Adrian mentioned there's a little bit more to doing UT with a drone than just cable tying some a D meter onto it. I think Danny and Cortland covered most of the main points about where the Elios UT fits in, and the other ones in the market. But the main thing from my perspective is it's a drone that's been designed to take contact repeatedly, and UT is a contact sport, contact technique. The platform was suited to doing UT before it even was, before that marriage took place, and it worked from the start. Even on the early prototype Elios 2s, where we were doing UT with them, and up until last year, still using those prototypes. That's for me the differentiator with this platform to the other ones that are in the marketplace. It's robustness, and it can repeatedly take those hits.
Thank you for these words. I have a question for you, Stefano, because I think you've been. We're talking about robustness and accuracy and so on, and we always forget, but we have a big partner behind this product, which is Cygnus, and you've been involved with them in making sure that the product is good. So what role have they played, and how did you leverage their 40 years of experience?
So yes, the reason why we work with Cygnus is because we wanted a partner with experience, and our job is to make drones, not to deliver a UT reading. So we need someone who delivers UT readings, and the goal of having someone like this is to certify that the measurements are good, and to take advantage of their experience on that. So Cygnus certifies all the measurements, the boards, and the equipment for us, and we have also help from the Cygnus partners, resellers, and stuff, to calibrate the equipment yearly, which is required in the industry. So yeah, that's about it.
Yeah, well, they even came to our office to do a final product acceptance. This was a 2-day event, and I think they played a huge role in that as well. So maybe you.
Yes, we were all very excited about that actually, because we take their equipment and we put it on the drone. And then we, as engineers, we are stressed because will they accept what we did? Is it good? Is it not? And I think everybody was happy that day. So extremely exciting time to be in, and it was just a few weeks ago, and now with this event. So yeah.
Felt like going back to school for the end of year final test, well, and kind of yeah. They've been pretty hard on us, but for a good reason. I'd like to. Oh, sorry, that's for later. Not yet. I think I'd like to hear a little bit about more specifically on the features that this drone and this integration delivers. If there's one specific feature that you would highlight and that you like particularly, I don't know if any of you want to take that question. Cortland, do you want to start?
The couplant delivery system is ingenious. To your point, I mean, normally we'd have that ability directly with the surface interfacing there to be able to ensure that coverage. But the way that is delivering that couplant, which, like you said, is paramount for UT, is ingenious. So well done.
I think we have to thank our engineers that are, by the way, watching for sure the live stream.
Yeah.
For that.
Nice work, everybody.
Danny, do you have any key highlight on this product that you'd like to talk about?
I believe the ability to see the A-scan live and to have the recording of the A-scan is very advantageous for building the trust with the end customer, end user. Having that transparency where you have the full recording, so if you need to escalate it to your level 3 or something like that, you have that ability. And that seems to be something unique that I have not seen out there is the full transparency on the A-scan.
And you, Malcolm, do you have any preferred feature?
Yeah, I mean, I think really to what Danny said there, the key difference for this than a standard by hand gauging is that typically as an inspector goes out, they take a reading, they'll write that down on a drawing by hand, or somebody that's working alongside them will write that down by hand. This is recording everything, and in the workflow to get to the report, there's far fewer steps where you've got human boredom, like writing stuff down on a bit of paper and then punching it into a spreadsheet, which, if you're doing thousands of readings, which sometimes on the projects for a ship inspection, we're taking 2,000 to 3,000 readings per vessel. So, that takes out a huge amount of, potential risk to actually get the wrong information into the asset management system. I think it's great.
Good. And a specific question for you, Stefano. I'm curious to hear what's the first question a client would ask when they see that? What's their first reaction?
Oh yeah. First of all, they want to see it fly, but then the first thing they do usually is they compare the reading with their instruments. So they draw a little circle and like, can you measure here? And then they measure with their own instrument there, and they're like, okay, yeah, more or less. And when we calibrate it right, it works right usually. So yeah, as it was a quite asked feature to compare every time. So we collaborated with a level 3 UT inspector. To make a comparison on paper and signed, so that now we can answer the question to everyone, and we don't have to do it every time. Every time we do a demo, hopefully. But yeah,
I can elaborate on that a little bit too, because I've been in this world for a couple of years now, and as a UT guy, I have been doing exactly that. As part of our workflow, we would go and make a circle, mark it out, date it, and take a conventional thickness reading, and then use drone UT. The UT is UT, right? So if it's in there the same way, it should be pretty close. But across all of our inspections, we haven't had anything out by more than about 1% on the whole on any ever comparison. And at that point, unless you cut it open and do a micrometer reading, whose system is right? The drone might be more accurate.
Yeah. No, and it feels that there's some attachment to your own equipment, the one that you trust. So hopefully people out there will trust as much this product today. Now I'd like to open doors a bit to the future. I think this product is here today, and we can't wait to see what you guys are going to do with it, and waiting for the LinkedIn posts with popping up. I mean, I think my LinkedIn is all about Flyability. I think their algorithm is doing right. But anyway, so what are the things that are probably missing or still to be improved, and things that are not there that you'd like to see in the future? What's the future for UT, for you guys on a drone?
Is this more of like what we're asking Flyability to build for us?
Well, you can hint on that as well if you want, but more specifically on UT first.
I would say seeing it deployed at scale and having it as a unique, everybody always uses tool in a toolbox. Maybe not like on that level, but in the sense of having it integrated into large projects. I think that's probably what's going to get me the most excited, is to see the adoption of it as a new way of doing things. And then I think that it aligns with everything that Flyability is building, is how to be more repetitive with the data, right? How to use some of the projects that are going on right now to get the aircraft to the same spot and start to do these things better than they've historically been done. Like Malcolm said, like just the paper trail it's amazing, right? If you can avoid pencil whipping in the industry, you've solved a huge problem. So,
yeah. If we're talking UT wise, I've said today a couple times now that spot readings can be fit for purpose, general corrosion and as a tool to screen. But sometimes based on the expected damage mechanism, we need to scan that it needs to be a continuous UT scan to look for things like pitting, as an example, or defects within, right, or deficiencies, depending on the code and how that gets called out. But seeing spot readings evolve into the ability to scan a location would knock down a lot of client doubt or make it fit for purpose in more environments.
And you, Malcolm, is there anything you would love to see in the future?
I mean, yeah, I was going to use Cortland's example there, but I guess if you take it a step further, there's then, you could use the Elios as a delivery tool for even more advanced NDT applications or UT applications, things like touch point corrosion, which is a big problem in refining, where pipes are sitting on pipe supports. But to do that, you'd need to be looking at phased array. So you have what Cortland talked about, being able to do B scan, C scan, corrosion mapping, and then going into sort of multiple probe head phased array. That would be the following step, and then that's you just about got to the complete pyramid. Yeah, it'd be very few tasks you couldn't do.
And I know you've been a big supporter of the workflow of capturing this data. I think you had a few ideas that you shared with me a few days ago regarding workflow of data and how this could be extended further than the drone, actually.
Oh yeah. Do we want to talk about that just now?
You can.
Well, I guess I mentioned, but previously, the current way that UT is done by hand is, it's fairly archaic in the reporting procedure and everything, and also the recording of data. And actually, if you take the flying part out of what the Elios 3 is able to do with UT, and create some sort of product that worked by hand, that a normal inspector, because this is covering maybe 10-15% of the areas on a ship for ship inspection. The rest is all done by gauging by hand. But the workflow with this is way better than the workflow of the traditional inspection. So you're working with two different workflows. You could have the whole workflow done with a device that's recording, 3D scanning your environment, and taking points.
Like a cuff with the LiDAR on your wrist.
Yeah.
Yeah, those are good ideas. I think that opens up minds and creates possibilities for the future. Stefano, actually, what else is Flyability considering for the future? Can you hint on a few things? Not saying all the secrets, but
well, all I can say is that we have a connector that has much more than just UT signal, so we can imagine to attach other stuff in there. I mean, scanning could be interesting. We could look into that as well. And EMAT could be also something that we could put in there. And I think EMAT could be interesting in different situations because it's a bit complementary. There is an overlap for sure, but EMAT can do maybe high temperature stuff and stuff like that. So maybe, I don't know.
Yeah, we'll see. That's the future, but at least we have a good idea of some of the things we could still improve. Just to wrap it up, as we're slowly getting to the end of this panel, I'd like to know if there's, one recommendation that you guys would have that you've gained through your experience with our product that you'd like to share with our audience, so that if you want to get started with their product, they have some recommendations from you. I don't know if there's any. Cortland is seen be noting.
If you're not already really into the drone space, just it's important to understand when you go down this road that it's not just about buying the drone and letting her rip. Take some time to consider your whole program. Just look at the big picture. This might be 10% of the entire workflow or an entire program. So it's just, it's not incredibly difficult to get going, but it needs forethought. So that would just be, if you want to succeed, take the time, put a little thought into it, and then this is the tool for this type of work. So that would be it. It's not really a secret, but that would be it.
Anything to add, gentlemen?
I would go back to the education point, is that education is key to everything we do here. It always has been since the beginning. I'm not an educator by trade or anything like that. I just have noticed the trends over the past 10 years, and that's what it takes, is persistence and transparency and educating people on boundaries, what it's good for and what it's not good for. That sometimes gets missed, so education.
Yeah, and just to, I guess, reiterate both those points, it's knowing and understanding the limitations of where to deploy it, what you actually want to do, and finding out where this potentially fits as a tool within your NDT program.
I'll probably, just to kind of on my end, to wrap up on my end, I'd go back to what Danny said earlier about collaboration. It's, if you look at visual inspection, there's no one tool that ticks every single box. And we'll see a similar situation in physical NDT. So this is going to solve a lot of problems, but not all. So if you're looking at a program, that collaboration and being open to the different tools that satisfy a program as a whole and make all of us, whether it's manufacturer, asset owners, service providers, anybody, we all win-win-win, to Danny's point, by looking at it through that lens.
Stefano, do you have any recommendation actually?
No, but I have some thanks to do, maybe. Because this tool was not, I mean, I'm presenting it, but it's not me, it's a lot of people, including those guys here, all the product advisors. And I have also to thank all the Mecha team, all the Flyability team, sorry, because I was part of the mechanical team, so I'm biased. But, and of course, the Cygnus team, which was very, very supportive. So yeah, big thanks to a lot of people for this project. It took a lot to make it happen.
All right. So with those words, we're going to put an end to that panel. We want to thank you all in this room. Thanks everybody as well who are behind their computer watching the screen, because this entire event has been live broadcasted. It's been a real pleasure to be here. And again, thank you very much. And to you behind your computer, see you very soon.